Complex socio-environmental problems are all around us today. Locally, regionally, and globally, these problems span many issues and many environments. To address these problems requires full participation in decision-making from multiple disciplines and experiential perspectives. But in complex situations, it can be hard to make sense of the multiple dimensions and processes at play, and to prioritize impacts and pathways forward. Participatory modeling is one way to address this challenge. Welcome to this tutorial video on participatory modeling. I'm Moira Zellner. Today, I will show you how my colleagues and I have used a range of modeling approaches with stakeholders engaged in participatory decision-making processes. I will start by defining participatory modeling and its utility to tackle complex socio-environmental problems. Next, I'll discuss the core challenges related to the process, followed by a framework of practices that our group has found to be important for increasing stakeholder engagement and consequently, productivity of the process. To ensure that participatory modeling is useful, some important parts of the process are critical, and I will highlight a few. I will then illustrate many of the processes using a platform that my team at Northeastern University has developed. I'll close with a few words about why participatory modeling is worth it. Participatory modeling is a collaborative approach to formalize shared representations of a problem and through the joint modeling process, propose and test solutions to that problem. It links science and modeling with diverse stakeholder expertise and values. And most importantly, it uses modeling to support collaborative decision-making to co-produce and synthesize knowledge about a complex problem and potential solution paths. While science has traditionally emphasized objectivity, rationality, and expert-driven data collection and analysis for problem solving, participatory modeling emerges within a larger trend toward democratizing science for social learning and collective deliberation through iterative participatory processes. It is particularly well-suited to address complex social and environmental problems like climate change, social and economic injustice, and sustainable resource management, where interaction among multiple actors and factors make the causes and consequences of the problem unclear, and where a diversity of values and perspectives may lead to conflict about concrete pathways forward. Engaging in participatory modeling helps elicit and harness diverse kinds of stakeholder knowledge, formal or informal, explicit or tacit, scientific or experiential. So it helps move from focusing on conflict to building collective solutions, strengthening relationship building, empathy, trust, and system thinking. All of this increases the quality and durability of decisions that take place during the process. In recent years, and thanks to succinct support, scholars and practitioners who develop and conduct various forms of participatory modeling have come together as a community to coalesce this rapidly growing application of knowledge co-production. This has helped streamline the field in terms of standards for consistent reporting of participatory modeling cases, lessons learned, insights into aligning modeling approaches with problem types, and assessment of modeling products. Recently, Beatrice Hedelin and I worked with colleagues on a synthesis of case studies. This, and work by others, has contributed to the accumulation of experience on the various dimensions of participatory modeling that need improvement. Most notably, assessment of the modeling products and outputs. Despite all this potential for participatory modeling to inform planning and policy, this practice has yet to become a mainstream approach in planning and policy. The reasons are several, so let me mention some of the key challenges. First, it is hard to standardize the approach, as it must be heavily tailored to the characteristic and context of each planning problem, the urgency of the problem, and the diversity of and power relationships among stakeholders. Second, it requires a broad range of skills, not only domain knowledge, but social skills and technical skills, such as those associated with modeling and visualization. This range of skills means diverse collaborations are needed, which can also be a major challenge. Participatory modeling is improved by experience in facilitation and evaluation. And of course, financial commitment is needed to support and build the systems and tools that allow users and planners to test solutions to the problem, build capacity of facilitators and stakeholders, and create new insights to support democratic processes. The challenges are currently being addressed with more research on knowledge co-production, social learning, and ethical participation in scholarship practice, and more recently, in funding agendas. Much of the development of participatory modeling practices has focused on modeling tools and engagement techniques. However, to be effective, the focus must go far beyond modeling and engagement. I'll talk now about many of these and more generally about confronting the many challenges. Working with collaborators, I have developed a framework that explicitly acknowledges and integrates the relevant practices and techniques to guide the design of effective participatory modeling processes. Instead of focusing on the initial problem definition step, I will focus on aspects that tend to receive less attention and highlight what needs to be done. Developing profiles that reflect the diverse concerns and working with stakeholders to prioritize them is a critical step before moving on to co-develop models and move towards simulation and implementation of solutions. And these priorities must be made explicit, but the methods used to accomplish this may affect the prioritization itself. There are always many priorities on complex problems, and no single solution works for each person. For a democratic process, extensive deliberations must occur to reveal the different views and priorities. For example, a green infrastructure plan to tackle urban flooding may be very effective at capturing water through infiltration and storage, yet be prohibitively expensive for some communities to build or maintain. Or for areas that routinely flood, it may be more affordable to move households, yet residents may not be willing to leave their homes and their lifestyles and livelihoods behind. What is a better solution, and according to whom? How can these trade-offs be addressed in an equitable manner? Dealing with such issues is easier for the group if they can visualize the diverse views and potential solutions. Even when there are outliers, these can support productive conversations, innovation, and compromise. The next steps are co-identifying social and environmental variables that stakeholders care about, and then conceptualizing the relationships between those variables. In traditional scientific modeling, this is done in a modeling framework. But because models are foreign to many stakeholders, this can lead them to question the models as invalid or untrustworthy. To avoid this and continue with co-generation of knowledge around the problem, it is useful to build together conceptual diagrams or other simple tools that at least align with the modeling technique. While some stakeholders remain engaged at some level as the modeling effort transitions from qualitative to quantitative, most prefer to stay at the conceptual level of involvement. And doing so can be indispensable for keeping collaborative model building and sense-making stakeholder-driven, even if the coding is not. Choosing a particular modeling technique, such as a system dynamics approach that matches the complexity of the problem while engaging with a broad range of stakeholders, can bring tensions, especially if stakeholders are not open to experimenting with that technique. But keeping stakeholders engaged in conceptual reasoning using tools that match the technique can reduce those tensions. For example, stocks and flows diagramming tools could be used for system dynamics modeling or class and activity diagrams for agent-based modeling. Even so, the process of conceptualization and simplification, that is, drawing the model abstraction from the complex lived experience, is not straightforward even for seasoned modelers. Depending on the specific stakeholders involved, certain aspects of a complex problem may not be represented or may be deemed of little value. In addition, participants may have diverging understandings about the way in which certain system components may influence others, or how to conceptualize such influences. Allowing for extensive deliberation during model construction can address such barriers, and when not resolved, can help develop hypotheses to test through modeling. Another approach to ensure diverse aspects of the problem are represented is to iterate the process with different groups of stakeholders to achieve model saturation, a stage in the model building process where no new components or mechanisms arise from stakeholder engagement. Ultimately, the modeling process must be useful in testing different decision scenarios that support the design of policies. While significant insights for decision-making may have been derived from the co-development process, ensuring the modeling is useful requires a focus on accessibility of the model to a broad range of users for scenario development and exploration. It also requires meaningful visualization of outputs to support the deliberation of trade-offs and compromise-seeking behavior. Unless directly involved in model co-construction, the learning curve to use complex systems models may be very steep for novices. As the number of parameters increases, so does confusion about why the outcomes are the way they are. Without clarity, it is hard to suggest what kind of policies and where they may be implemented to make a difference in the desired direction. The ideal number of system components and variables in a model is something to be collectively defined and tested for each problem and set of stakeholders. Too many variables will make it hard to explore solutions and can quickly overwhelm the participants who are trying to consider potential solutions. Too few variables may leave out critical components that some participants value, so excluding variables should be deliberated on and agreed upon. Outsourcing the analysis should be avoided because it deprives stakeholders of the experiential, collaborative design and exploration of new interventions and sense-making of their outcomes. Without these experiences, it can be hard to trust the results coming out of proposed interventions, and more generally to adopt participatory modeling as an established practice for institutional decision-making. This can leave participatory modeling as an isolated intellectual experiment. Let me mention a few things that can minimize this. First, translating what participants learned into specific policy suggestions and concrete plans is essential, even if it means governance changes. This is not easy, especially if the modeling results conflict with pre-established favored solutions. Second, because trade-offs will emerge from each solution to a problem, these should be explicitly discussed and the solution's impacts be monitored and managed over time. Third, it is critical that participants be aware of the social learning they're engaged in. This can be accomplished by illuminating what was learned during discussions or by using pre and post surveys to show participants how much they have changed their views. Even in light of the understanding supported by participatory modeling and full discussions of trade-offs, unanticipated or unfamiliar effects and perception of risk often generate resistance. This resistance can arise if participants interpret the inevitable uncertainty of complex systems as doubt rather than as a range of possibilities. And this can feed into collective ambivalence about pathways forward and anxiety about the lack of accuracy. So a fourth way to minimize the potential for participatory modeling to become just an isolated experiment is to emphasize that uncertainty is inherent with any change. Moreover, it is even present when no change in policies are made. Instead, encourage the group to focus on the most robust policies that would be effective in a variety of possible futures. To help deal with the complex issues I have raised and help guide participatory modeling in practice, I'm excited to introduce you to fora.ai, a new whiteboard platform developed at Northeastern University. Foraai is designed to support and scale up collaborative modeling and planning. It allows groups of stakeholders and decision makers, including scientists, modelers, citizens, and public officials, to collaborate for climate and social justice solutions. The platform allows users to define the problem, set the priorities, then co-design different solutions with others, run simulations to test these solutions, and deliberate about the trade-offs that emerge from each solution. This deliberation feeds back into solution co-design and testing, and sometimes even in the definition of priorities or the problem itself. Priorities are set by ranking individual preferences and their relative importance. Variables are used to represent the interests that participants have collectively defined as important. Once ranked, weights are provided as default, but users can adjust them so that the relative levels of importance across the variables can also be represented. For example, in the case of flooding and green infrastructure that I mentioned earlier, engineers might want to prioritize infiltration over everything else, while public officials may want to minimize investments and maintenance costs, and residents may want to minimize property damage. In foraai, individuals can view these diverse priorities, whether they are sharing a collaborative session or not. This can support productive conversations around what people care about. In one of our projects, a spatially explicit process-based model that we developed called Landscape Green Infrastructure Design, or LGRADE for short, is being integrated into foraai. Participants work together with this model to design solutions to urban problems, including flooding, by placing green infrastructure tokens on their community map. Through the foraai's whiteboard, participants have the ability to comment, ask questions, flag things, and get more detailed information about the interventions. They can also click on each landscape tile or cell to get more information about the place through layers of spatial data like elevation, land cover, and such. Proposed solutions, once co-designed and finalized, can then be submitted for simulation and evaluation, where the areas of higher impact can be quickly identified and viewed from different perspectives and over time. From direct engagement in the development and use of the underlying L-grid model, the platform supports understanding of the biophysical phenomena. That makes teams better prepared to plan interventions to produce desirable outcomes. Simulation results from this and other models cannot by themselves provide answers. Human judgment must be involved in what the desired solutions and priorities are. This is what makes it a democratic process. And foraai supports that process by evaluating simulation results through the different concern profiles entered by participants. It highlights how each variable of interest contributes to each person's concerns, quickly identifying what the trade-offs are and what is driving them. The results are compared against a baseline with no intervention, as the intent is not accuracy, but relative improvement across scenarios. This feedback provides a basis for informed deliberation, where differences are a source of innovation more than conflict. The iterative facilitated process of scenario building, testing, and deliberation supports productive collaboration towards implementable compromise solutions that we can all live with. In this manner, foraai democratizes decision-making through inclusive engagement in modeling and solution building, empowering communities with science and evidence-based reasoning, while harnessing their innovative capacity to jointly create pathways towards climate resilience and social justice. While we're very excited about what foraai can help us do, we're also mindful of the critical role that both facilitation and evaluation play in the successful use of such tools. Facilitation has been covered elsewhere, so I'll just mention a few things about assessment before my closing. Currently, there is a paucity of assessment in participatory modeling studies, particularly aspects of engagement. Instead, assessment tends to focus on participant satisfaction through pre- and post surveys. More in-depth assessments should focus on interactions among participants and with the modeling tools and simulations. Ideally, these would occur not only after engagement to look for changes, but across the entire modeling process. Assessments done during interactions allow for opportunity for reflection and feedback from the participants. This opens the door to better understand the transformations that participatory modeling fosters or not, and to adjust models, interfaces, and facilitation practices to better support the process. This can also lead to refining the pre-established goals and priorities of the participants as new knowledge is co-developed and values and preferences co-evolve. To enable this kind of assessment, we are building into fora.ai the ability to collect data from participant use and the ensuing scenario development, deliberation, and policy formulation. Participatory modeling is transformational, but requires a lot of work and long-term commitment and resources. Is it worth it? The evidence we've collected from our work suggests it is, even with so-called failures. The reasons are multiple. First, people have habits of practice and thought that distract them from discovering new possibilities. By visualizing and discussing complex biophysical processes at play and trade-offs around diverse values, participants are empowered to see gaps and differences and discuss whether and how to address them. Second, it's worth it because far too often communities work towards compromises that move plans further and further away from specifics until what emerges is a generalized best practice. This may gain consensus, but is so vague that it no longer holds any meaningful guidance. So, for example, plans may end up as, whenever possible, we should favor green infrastructure, instead of we should put this type of green infrastructure here. When participatory modeling processes are used, work is done to resolve conflict, not just push it back. Third, innovation happens through relationships with other people and can be enhanced by the use of tools as prosthetic devices for collaborative thinking and design. Models, interfaces, and facilitation structures need to be designed in ways to aid exploration, the evolution of understanding and valuation, allowing people to explore new possibilities, examine their expectations, and make practical judgments to plan for the future. We believe that consequences can be significant. The approach I have outlined supports a democratic process of working with difference rather than trying to eliminate it. And evidence is brought to bear through modeling, which allows true compromise to be reached in an informed way and in consideration of trade-offs. This evidence also allows for deliberation on how to best address the negative impacts of a chosen solution and ensure the fair distribution of the positive ones. Participatory modeling built upon socio-environmental systems modeling is a critical source for this kind of evidence. Thank you for listening. Please now enjoy comments by our panel of participatory modelers.